Hey, how's it going everyone? Welcome back to the channel. And today's video will be a very special one because at the time of recording, we've just hit 100 subscribers. So this is quite a big milestone for me in creating this channel. So a very big thank you to everyone who subscribed, and hopefully you're all enjoying the content that I am putting out on this wonderful hobby of RC submarines. So if you've been following my other videos recently, you know that my current project is actually this little boat right here. This is my 1/35 scale German Type 2 U-boat. And with mid to large size RC submarines like this one, the extra hull space inside means that we have extra room for some goodies. And as you probably guessed it from the title of this video, today's topic will involve functional torpedoes for RC subs. This is a model of a German G7 torpedo, which is a standard issue torpedo for the Kriegsmarine. And very much like their real counterparts, torpedoes for RC submarines are usually divided into two main propulsion methods, rather. So the first one being compressed air power, and the second one being electrically powered. So in the case of a compressed air torpedo, you would have something like a resin molded torpedo body or something fabricated by the operator. And at the tip of the torpedo would be a small valve to load the compressed air into the torpedo body. So most of the torpedo body would be empty space for the compressed air. And towards the stern, the back end of the torpedo, you would have a small rubber nozzle where you would insert a little pin to keep the air from escaping. And to activate the torpedo, a servo or some sort of spring mechanism would pull out the pin and thereby freeing up the nozzle and letting all the compressed air escape and propelling the torpedo out of the tube. In the case of an electrically driven torpedo, you would have something like these. These are very small drone, RC drone motors. So very minuscule, very tiny electric motor driven by usually something like a, I think 1.5 volt AAA battery or a small lithium polymer battery cell. So in the case of an electrically driven torpedo, this would be connected to a set of propellers, which then simply propel the torpedo through the water. And the tricky thing with electrically powered torpedoes is that if you don't have some sort of limit switch inside or a timer circuit, the torpedo would kind of just run until it hits the edge of the lake, the pond, or the pool, and it'll kind of keep spinning. I have seen designs where somebody would actually have a little sort of, I guess, a little safety switch at the tip of the torpedo, where when the torpedo hits the edge of the lake or any kind of hard surface, it simply turns off the circuit that's inside. So that's one way of assuring that you don't waste any battery for your electric torpedo. So in my case, for my U-boat, I did consider using an electrically powered torpedo. I didn't quite like the gas power, since I really don't have the tools or equipment to make resin cast torpedoes or weld, I guess, metal torpedoes to ensure that it's a safe container for the compressed air. So my choices were always revolving around, I guess, electrically powered torpedoes up to this point. But lately, I've wanted to fiddle with something that I've been thinking about ever since I started in the hobby of RC submarines, and that's something called a rubber band powered torpedo. So in this case, this is a little test torpedo that I rigged up using some standard, I guess this is just standard PVC piping that you see under your sink there. I'm not sure on the diameter of this piece. I didn't measure it, but you can tell that compared to a 1/35 scale torpedo, it's actually quite close. The diameter is just a bit smaller, but very, very similar. So in my case, I wanted to experiment with rubber band power because I feel that it's actually a very dead simple way of propelling a torpedo through the water. So if we move from the front all the way to the rear, you can see that at the tip of this, inside here is really just a standard heavy-duty rubber band that you see being used on those rubber band powered model airplanes that we've all played with when we were kids. So I have a small 3D printed, torpedo tip right here, inside which is a little, if I can break this open, a little bit of weight that I put in at the front. These are just simple nuts that I took from my hardware box. So this really keeps the nose of the torpedo underwater and keeps the torpedo usually a bit neutrally buoyant. So inside the torpedo body is where the elastic actually resides. Towards the stern of the torpedo is where the elastic meets the drive shaft of the propeller. So as you can see, if I remove the rear nozzle here, inside there is a small brass propeller shaft that's attached to this, second set of four-bladed propellers. So this whole shaft is tied to the rubber band, very much like a rubber band powered model airplane. And you might be wondering what the second set of propellers, what the first set of propellers does. And this is because when the rubber band is wound up and unleashed, it causes the torpedo body and the second set of propellers to rotate because of, the conservation of angular momentum. So when this torpedo is traveling through the water, the body would be rotating in one direction, and the little second set of propellers on the side, on the end there, will be rotating in the opposite direction. So I fitted a set of propellers to the torpedo body itself so that I can make use of this counter rotation to drive the torpedo forward. And this counter rotation not only provides propulsion, but also helps to stabilize the torpedo in the water, very much like a bullet exiting the rifling of a tank barrel, for example. Some of the holes I've drilled inside the body allows water to free flow throughout the torpedo, because I don't want this to actually float on top of the waves, because otherwise, without the holes there, this would be very much positively buoyant, and you won't get any kind of propulsion out of these propellers in that case. So to wind this torpedo is very, very dead simple. Either I can wind it up by hand, or I can see at the tip here, I've actually glued in a plastic rod so that I can simply wind it up using my power drill. So speeds up the process much quicker. So I'm going to move to the bathtub next so that I can show you this little torpedo in action. Okay, so I've spun up this torpedo using my power drill for about 15 or 20 seconds or so. Not sure how many turns of the rubber is in there, but I do feel quite a bit of tension on my fingers as I'm holding the two sets of propellers, preventing the torpedo from unwinding itself. So what you see is I'm going to drop the torpedo in this end of the bathtub, and hopefully it's going to travel in a straight line and shoot towards the other side. Don't have that much room lengthwise to run this, so most likely it's going to hit the edge of the bathtub over there and keep spinning on its own axis. So I'm just going to submerge the torpedo, making sure that it's completely underwater and all the air bubbles has escaped from the body. And here we go. So you can see that quite a bit of power unleashed there at the beginning. The thing with these rubber band powered torpedoes is that I think they like to unleash or release all their energy in a very, very quick burst. So promising results so far. I mean, I do like the fact that it is able to travel underwater in a somewhat straight line. And I think had it not been for the edge of the bathtub right here, probably would have gotten just like 2 or 3 feet of range right there out of this torpedo. In total, I think given the length of this bathtub, maybe this thing can travel as far as maybe even 5 or 6 feet. I'd be happy if that was the case. All right, so back on the workbench. So what I did notice through some more tests is that there seems to be a kind of optimal winding time with the power drill of about 15 seconds. Past more than 15 seconds, what ends up happening is the rubber band is wound so tightly that it actually ends up breaking, like it did here on an earlier test. So what also ends up happening when I wind this up too much is the propeller spins up so fast that I think what happens is there is a kind of cavitation effect happening where the energy is unleashed in such a quick burst that the small air bubbles start to form around the propeller blades in a very short amount of time, preventing the blades from actually biting into the water effectively. And what ends up happening is the torpedo just sort of spins on its own axis in one spot without going forward much. But hey, I did get this thing to run in the water for a little bit, for a couple of feet. So that's already a good start. Getting this to run in the water is one thing, but getting this to launch out of a RC Submarine torpedo tube is another matter. So that's going to come through future tests of this little torpedo system. Hey, but so far I am a bit optimistic on getting this to work effectively. So stay tuned as I explore this little propulsion method further. So like always, remember to give us a like and a subscribe. This does help the channel quite a bit, and hopefully we can get to, I guess, 500 subscribers in a couple of months. Let's see if we can make that happen. And until then, hope you are all staying safe, and we'll be back very, very soon for more RC Submarine videos. Take care.